In our letter A problem, we have f of s is equal to 2 over s cubed minus 4 over s minus 1 raised to 4 plus 25 over 2s minus 18 all raised to 5. So in order to get the inverse Laplace transform, we have inverse Laplace transform of 2 over s cubed minus inverse Laplace transform of 4 over s minus 1 raised to 4 plus inverse Laplace transform of 25 over 2s minus 18 raised to 5. And this can be equal to t raised to 2 minus, we will take out 4, we have 4 inverse Laplace transform of 1 over s minus 1, and this can be, we will make it raised to 2 plus 2 and plus 1 half, so that will become inverse Laplace transform of 25 over s minus 9. We will make it raised to 2 plus 3. This will become to t squared minus 4, and this can be equal to e raised ang 1. This can be equal to e raised to t inverse Laplace transform of 1 raised to s4 plus 1 half. And we will make it times 25 over 3, so that it will become inverse Laplace transform of 3 over s minus 9 raised to 2 plus 3. This can be equal to t squared minus ito ka mo 4 over 3 e raised to t cube plus 25 over 2 times 3 is 6, and this will become this is equal to sine of 3 t inverse Laplace transform of 1 over s raised to 5. This can equal to t squared minus 4 over 3 e raised to t e raised to t and t raised to cube plus 25 over 6 times sine of 3t, and we have 1, and to balance this we have to divide 4 the outside, so we have inverse Laplace of 4 raised to s 4 over s raised to 5. And the final answer is t squared minus 4 3 over 3 e raised to t cube plus 25 over 6 sine of 3t 1/4 and t raised to 4. And this is our final answer. In letter B, we have d of s is equal to 4s over s squared minus 10s plus 26. So to find the inverse Laplace transform, we have inverse Laplace transform of so first we will take 4 out. We have 4 Laplace transform of negative Laplace transform of s over s squared minus 10s. This will become you can make it plus 25 minus 1 plus 1, that is equal to 26. And we have 4 inverse Laplace transform of s, and to simplify this we have s minus 5 squared plus 1 This can be equal to 4 inverse Laplace transform of, we can make it s minus 5 plus 5 over s minus 5 all raised to 2 plus 1, and we have 4 inverse Laplace transform of, we will separate this. We had s minus 5 over s minus 5 raised to 2 plus 1 plus 5 over s minus 5 squared plus 1, and we can have 4 e raised 5d, because this 5 over s minus 5 for this raised 5d, and we have inverse Laplace transform we have of s over s squared plus 1 plus, and this is also e raised to 5d plus inverse Laplace transform of 1 over s squared plus 1. And this can be equal to 4e raised to 5d, and this is equal to cosine of t plus e raised to 5d, and this is equal to sine of t. This is our final answer. Letter C, we have h of s is equal to 3s plus 5 over s squared plus 22s plus 117. In order to find the inverse Laplace transform, we will take out 3 inverse Laplace transform of, it's going to be equal to s plus 5 over 3 over s squared plus 22s plus, we will make it 121 minus 4. That's also equal to 117. Equal to 3 inverse Laplace transform of, we'll simplify this. We had, in order to balance, we will make it s plus 11 minus 28 over 3 over s minus s plus 11 squared minus 4. It can be equal to 3 inverse Laplace transform of, we'll separate this. It will become s plus 11 over s plus 11 squared minus 4 minus 28 over 3 all over s plus 11 squared minus 4. And we had 3. This can be equal to e raised to negative 11t inverse Laplace transform of, left is s over s squared minus 4. And we will take out 28, and 3 times 11 was 33, so that we had inverse Laplace transform of 11 over s plus 11 squared minus 4 will be equal to 3 times e raised to 11t. This is equal to hyperbolic cosine of 2t minus 28 over 33, and we had times e raised to 11 negative 11t inverse Laplace transform of 1s over s squared minus 4. This will become 3e raised to negative 11t hyperbolic cosine of 2t minus 28 over 30t e raised to negative 11t And in order to balance this, we will divide it to 2. And we have inverse Laplace transform of 2 over s squared minus 4. And this will equal to 3e raised to negative 11t parabolic cosine of 2t minus 28 over 33 e raised to negative 11t times 1 half, and is equal to hyperbolic sine of 2t. And this is our final answer. In letter D, we have y of s is equal to 4s minus 11 over s squared plus 24s. So to find the inverse Laplace transform, this can be equal to, we'll take out 4, and inverse Laplace transform of s minus 11 over 4 all over s squared plus 24s equal to 4 inverse Laplace transform of s minus 11 over 4 all over 2 s plus s squared plus 24 plus 24s times 144 minus 144 and equal to 4 inverse Laplace transform of s plus 12 minus 25 over 3 all over s plus 12 s squared minus 144. And to separate this, we had 4 inverse Laplace transform of s plus 12 all over s plus 12s squared minus 144 minus 25 over 3 all over s plus 12s squared minus 144. This can be equal to 4 e raised to negative 12t inverse Laplace transform of s all over s squared minus 144 minus 25 over 3. We take out 25 over 3 inverse Laplace transform of 3. In order to balance our equation, we multiplied 12, so that our denominator 3 times 12 is become 36 inverse Laplace transform of 12 over s plus 12s squared minus 144. It's going to be equal to 4 e raised to negative 12t. This is equal to hyperbolic cosine of 12t minus 25 over 36. And this is equal to e raised to negative 12t. 12t. We have 1 over 12. Yes, 1 over 12. I mean, we will divide 1 over 12 so that we can have inverse Laplace transform of 12 over s squared minus 144. And this can be equal to 4 e raised to negative 12t hyperbolic cosine of 12t minus 25 over 36 e raised to negative 12t times 1 half hyperbolic sine of 12t. And this is our final answer. Letter E, we have f of s is equal to 1/3 s minus 5/4 all over s squared minus s plus 1 half. So to find inverse Laplace of the transformation, we have this can be equal to 1. We will take out 1/3 inverse Laplace of s minus 15 over 4 all over s squared minus s minus 2 plus 3 halves. This can be equal to 1/3 inverse Laplace of s minus 1 minus 19 over 4 all over s squared minus 2s minus 2 plus 3 halves inverse Laplace of. I will separate this. So we have s minus 1 all over s minus 1 squared minus s minus 3 halves minus 19 over 4 all over s minus 1 squared minus s minus 3 halves. Sorry, this is 1/3. And this can be equal to 1/3 e raised to t inverse Laplace transformation of s over s squared minus 3 halves. So we will take out 19 over 4. Inverse Laplace transformation of left is 1 over s minus 1 squared minus s minus 3 halves. This can be equal to 1/3 e raised to t, and this is equal to hyperbolic cosine of square root of 6 over 2t plus left is the inverse Laplace of 1 over s. Sorry, this is close parenthesis, 1 over s minus 19 over 4 e raised to t, since this is negative 1, and we have inverse Laplace of 1 over s squared minus 3 halves. This is equal to 1/3 e raised to t hyperbolic cosine of square root of 6 over 2t. Since this is 1 over s, inverse Laplace of 1 over s is equal to t minus 19 over 4 e raised to t times square root of 6 over 2 inverse Laplace of square root of 6 over 2 all over s multiplied by s squared minus 3 halves. This is equal to 1/3 e raised to t hyperbolic cosine of square root of 6 over 2 t multiplied by t minus 19 over 4 e raised to t times square root of 6 over 2. This is equal to hyperbolic sine of square root of 6 over 2 t and inverse Laplace transformation of 1 over s. And this is equal to 1/3 e raised to t hyperbolic cosine of square root of 6 over 2 t times t minus 19 over 4 e raised to t square root of 6 over 2 hyperbolic sine of square root of 6 over 2t, and this is equal to t, and this is our final answer. And in solving problems in calculation number 8, it helps me to familiarize the different methods of taking the inverse Laplace transformation and by solving it by using tabular method and 4B method.